Question 48. At 627 degrees centigrade and 1 atmosphere, SO3 partially dissociates into SO2 and O2. 1 liter of the equilibrium mixture weighs 0.94 gram under the above conditions. Calculate the partial pressures of the constituent gases in the mixture. 627 degrees centigrade means 900 Kelvin, that is 627 plus 273, this is equal to 900 Kelvin. Now the weight of 1 liter of the equilibrium mixture is given as 0.94 gram. So in other words, we can also say that the density is 0.94 gram per liter. Now the equation for the dissociation of sulfur trioxide is SO3 dissociates into SO2 and O2. The balanced equation is 1 mole of SO3 dissociates to give 1 mole of SO2 and half moles of O2. Now initially, if 1 mole of SO3 is present, then before dissociation, moles of SO2 is 0 moles and moles of oxygen is also 0 moles. Let the degree of dissociation be x. So, out of 1 mole, x moles of SO3 dissociates to give x moles of sulfur dioxide and x by 2 moles of oxygen. Applying the formula PV is equal to nRT, pressure is given as 1 atmosphere, volume of the mixture is not known, so let it be V is equal to N. The total number of moles at equilibrium is 1 plus x by 2. This we obtain by adding the total number of moles at equilibrium of sulfur trioxide, sulfur dioxide and oxygen. That is 1 minus x plus x by 2, and this is equal to 1 plus x by 2. This is the total number of moles into R. The value of R is 0.0821 into temperature. Temperature is 900 Kelvin. Solving, the volume is equal to 1 plus x by 2 into 73.89 liters. Now the formula for density is weight divided by volume. Now initially only sulfur trioxide was there and we have assumed that 1 mole of sulfur trioxide is there. So weight of 1 mole of sulfur trioxide is 80 grams. So weight is equal to 80 grams divided by volume, that is 1 plus x by 2 into 73.89 liters is equal to density, and density is given in the question as 0.94 gram per liter. Substituting the values and solving, the value of x is equal to 0.3036. So this is the degree of dissociation. Now partial pressure of sulfur trioxide will be equal to moles of sulfur trioxide at equilibrium, that is 1 minus x, divided by total number of moles, that is 1 plus x by 2, into pressure, the total pressure, that is 1 atmosphere. So 1 minus x will be 1 minus 0.3036, that is 0.6964, divided by 1 plus x by 2, putting the value of x, 1 plus x by 2 is 1.1518 into 1, solving, partial pressure of sulfur trioxide is 0.6046 atmosphere. Similarly, partial pressure of sulfur dioxide is equal to moles of sulfur dioxide at equilibrium divided by total number of moles, that is x divided by 1 plus x by 2. Putting the value of x and solving, the partial pressure of sulfur dioxide is 0.2636 atmosphere. Here it will be x by 1 plus x by 2 into 1, that is total pressure. Now partial pressure of oxygen is moles of oxygen at equilibrium, that is x by 2, divided by total number of moles, that is 1 plus x by 2, into the total pressure, that is 1. Putting the value of x and solving, the partial pressure of oxygen is 0.1319 atmosphere. Now there is another method to find the value of x. We can find the molecular mass of the mixture by using the formula molecular mass of the mixture is equal to dRT by P, where D is the density. Putting the values of dRT and P, the molecular weight of the mixture is 69.457 grams per mole. Now vapor density of the mixture will be equal to, it is denoted by small d, molecular weight divided by 2, which is equal to 34.728. Similarly, vapor density of sulfur trioxide denoted by capital D is equal to molecular weight of sulfur trioxide, that is 80 divided by 2, and this is equal to 40. Now applying the formula, X is equal to D minus D divided by N minus 1, where N is the number of moles of the product. So N minus 1 into small d. Putting the values, the number of moles of the product is moles of sulfur dioxide plus moles of oxygen, that is 3 by 2. So N minus 1 becomes 3 by 2 minus 1. So putting the values and solving, the value of X is 0.3036.